Welcome back once again, class 12 students. Now I am starting new chapter, new unit, current electricity. ठीक है, मैंने अपने पिछले वीडियोस में पूरा जो समझाया है वो समझाया है पहला और जो दूसरा यूनिट है, फर्स्ट एंड सेकेंड यूनिट मीन्स इन दोज यूनिट्स आई हैव टॉक्ड अबाउट electric charge at rest. Now in this unit we will talk about when charge moves. We will talk about properties, we will talk about current actually. Why current? Because when charge moves we say that when charge moves then there is a current. एक जनरल लाइन लिख दी मैंने, there is a current. I'll write this in a much better method, in a much better way. अभी एक सिंपल लाइन लिख दी मैंने कि whenever there is a movement of charge we will say that there is current. If you remember, then what was the name of first unit? It was electrostatics. Then what did we study in it? Electro means charge, statics mean रुका हुआ. So there was charge at rest in first unit. In this, charge was at rest. Charge was at rest. Now think of this name, current electricity. So when you listen this word, what does come to your mind? What kind of meaning you gather when you listen this word? It means the charge. Current means something moving. Current means motion. So we can basically say the whole thing is motion of charge. Correct? In simple words we can say, because current in simple sense gives a meaning that motion is there, right? So whenever there is current, there is definitely motion of charge, right? That is, whenever there is a charge moving, then there is current. Now we measure current and then there is a formula for measurement, but in general we can say that whenever there is a motion of charges, then we say कि current है वहाँ. ये this line and this line is almost same. There is not much difference in these two lines, right? So in this unit we are going to study the motion of charges, right? So if I write much better line actually, then I should write that study of electric charges in motion. Study of electric charges in motion is called current electricity. So this is very quick introduction of the chapter. I'll not talk much about the name now. So first thing which is important to understand for our syllabus is electric current. Directly moving to the points which we should study now. Electric current. Fine. So what is electric current? Just few, 1 minute back maybe, I told that whenever there is a flow of charge, we say that there is current, right? Then flow of charge constitutes current. Then if we talk about quantitatively means if we want to measure that flow, right, then the measure of that flow can give us the value, can give us the magnitude of current, right? Because please remember, magnitude is very important for every physical quantity, and electric current is a fundamental physical quantity. The whole current, whenever we study further in detail about the current, everywhere current is going to be used. This is fundamental quantity, so it is going to be used, and it is very important to measure this fundamental quantity, right? So quantitatively, what can we write? In first of all, I'll write a very simple line. Quantitatively, rate of flow of charge is known as current. Simple. Magnitude of current, rate of flow of charge. What does it mean? It means, for example, if a charge, let us say I write Q, or let us say delta Q, flows, or let us say passes through an area in time t, or I'll write it much better, t to t plus dt, delta t, right? That is in delta t time. Charge delta Q flows in delta t time. It means this. Then current is given by I equal to delta Q by delta T, right? To get most accurate value of current, most accurate value means instantaneous current at any instant, current at any instant means I instantaneous should be equal to limit, this instant mean time should be as small as possible, and then we can write this. I hope you are familiar with this term, because in class 11th also, when we talked about instantaneous velocity, I hope you remember, when we talked about instantaneous velocity, then we wrote, if you want I can remind of you of that term. Then when we write instantaneous velocity, then we write v equal to dx by dt, right? So this also I instantaneous will become equal to dq by dt. Here also this line came from v equal to limit delta t tends to 0 delta x by delta t, if you remember. Okay, anyway, if you don't remember, this is the revision of it also. Fine. So I instantaneous becomes dq by dt. Fine. So based on this formula, there can be some numericals as well. For example, I'll write a very simple numerical based on this. Let us say there is a flow of charge. Now example I am sharing with you all. Let flow of charge varies with time in a conductor and represented by or given by q equal to 3t square minus 4t minus 6t. For the calculation sake, I am making it easier one, minus or 12t plus 7 coulomb, right? Then this is coulomb. Then calculate current at t equal to 3 seconds. Number 1, for example, or number 2, when current was 0. right? We can also ask what is the maximum value of current. Anyway, so first of all, these two questions I will solve. So we are given solution now. We are given q equal to 3t square minus 12t plus 7. So we will differentiate it because I said that I is equal to dq by dt. So d by dt of q means 3t square minus 12t plus 7. And what are we going to get? 6t minus 12. This is the current, right, at any instant. Fine, at any instant. So at t equal to 3 second, I equal to 6 into 3 minus 12 means 18 minus 12, 6 ampere current is going to be there at 3 seconds. Similarly, second part, this was the first part. Second part, when was current 0? So I equal to 6t minus 12. If we compare it with 0, so it will give us t equal to 2 second, right? So at t equal to 2 second, current was 0, right? Fine. So this is a very easy question based on this. Next one now. Continuing with the topic now. So I was explaining current I equal to dq by dt, or I equal to in general q by t, right? In general, I is equal to q by t. In general, I equal to q by t, and we simply say it's rate of flow of charge. Rate of flow of charge. That means q charge flows in t time. This is very simple, very small, explanation of the formula. Now, unit of current. Unit of current. I think every one of you knows about it, but still I will be telling about it. SI unit of current is ampere, and we write it by capital A. So 1 ampere will be equal to 1 coulomb by 1 second. So 1 coulomb charge, if passes through a cross section, right, in 1 second, then we say that 1 ampere current is flowing through it. Smaller units also, if we want to learn, you should learn actually now, smaller units. For example, 1 milliampere, we write like this, is equal to 10 to the power minus 3. Whenever milli word comes, 10 to the minus 3. For example, 1 microampere, 10 to the power minus 6 ampere, right? I think these can be used certain times, right? Okay. Now, direction of current. Direction of current. So if we draw a very simple diagram, which you have seen in class 10 also. For example, this is a diagram, this is a resistor R, and this is a cell which applies or which maintains the potential difference across this resistor R. Fine. If you remember, fine. If you do not remember, current flows like this. Correct? I think you remember about it. Positive terminal is known as the terminal at higher potential. Positive terminal means higher potential. Positive terminal means higher potential. And negative terminal means lower potential. लोअर पोटेंशियल, ठीक है ना. फाइन. सो by the convention, the direction of positive charges is taken as the direction of current. So this is conventional. This is by convention. Current flows from higher potential to lower potential. That is why current is considered to flow from positive terminal to negative terminal. Fine. So this is conventional. But think, in reality, please think about it. In reality, electrons actually move in opposite directions. Electron move like this, E negative, they go like this. Electron goes in upward direction, sorry, in reverse direction. Fine. Electron is coming opposite to conventional current, right? So that is electronic current. I will write this, that will be better. So, but electrons actually move from negative terminal, that is from lower potential to higher potential, fine. And it is the direction of electronic current. So now what do you know now? That means conventional current +2 minus and electronic current -2 प्लस. एक डायग्राम बना देता हूं मैं. इफ यू कन्वेंशनल करंट ये मान सकते हैं आप कि पॉजिटिव चार्ज के मूव करने की डायरेक्शन, ये है कन्वेंशनल करंट. कन्वेंशनल. वाइल योर इलेक्ट्रॉनिक करंट इज जस्ट अपोजिट. दिस इज इलेक्ट्रॉनिक करंट. Okay, like this, opposite. This is electronic current, means direction of movement of electrons. Now since we are putting direction every time, but please remember, electric current is not a vector quantity. Electric current is a scalar quantity. It's not a vector quantity. Okay, and how do we understand it? Because in one line I will write, it does not follow vector law of parallelogram law of vector addition, because it does not follow parallelogram law of vector addition. You studied in class 11.